Give it a minute to think about. Oh, it says it will go live, right? It has gone live. Right click. Show me all the controls. Come on. Show me all the controls.
Oh, it looks like I missed a big day.
Right click. Yeah. Again, show me. There's all the controls. Yeah, well, you did miss a big day. Stuff you've never seen in your life. But we will be kind of practicing the stuff. So anyway, we finished up the notes for 2.4. We started in on 2.5. You can catch the rest of the notes in a little bit. When you get roll, I might even have some papers to pass back to y'all's. And so this time we got a mark Kylie absent. All right. So did you just get your 2, 3 turned in, sir? Good. Nope. That's not me. All right. Okay. I don't know why you do what you do. I don't know what you do. People do what you do. Okay. So we just got this 0.50 put onto an XY coordinate. Y'all with me? Because I'm teaching. Because y'all look like y'all are not really quite here yet. Okay. We need to track it using both of our bearing methods. All right. So it's interesting. It says express the bearing using both methods, but then they call the first one bearing, and they call this one direction, but we're going to use both methods. So I'm just going to say method 1. Method 1, how do I get, well, first of all, this is north, right? South, east, west. For the first method, where do I begin? I always begin at north on method 1, so I don't have to tell you I'm beginning at north because method 1 always begins at north. So I won't show any directions. And then what direction do I move from north? Clockwise. So for method 1, I'm starting here and going there, correct? How many degrees did I go? 90 degrees. All right. For method 2, I have 2 choices for where to begin. What are my 2 choices of where to begin? North or south. Why do I have 2 choices this time? Because a lot of times I don't have 2 choices. I'm right in the middle, so I'm the same distance from north as from south. If it's above the east-west line, you always start north. If the point were somewhere down here below the east-west line, like last time, you don't have a choice. I had to start with south last time, didn't I? Okay, so this one you can either say, I started from north, and then tell me how many degrees did you travel? Towards east or west? Okay, so that would be acceptable. Or, because I accidentally gave you this thinking, I thought there was an example like this. I forgot the example was down here. That's why I gave you the same one. What's my other option for going right there? I could start from south and travel 90 degrees, this time to the west? No, still going to the east. So the second method will tell me which pole I'm beginning in, north or south, and then how many degrees and which side. So I don't always go clockwise or always go counterclockwise there. Okay. So with those 2 methods now in the bag, we are going to do some problems, and in some cases, we will see one or the other of those methods used. All right. This next little problem, number 14, you've got something like this. I'm just going to read it to you and just see what you get out of what this says, okay? Because it's kind of one of those things you're going to go, what? So, the ray, y equals x, comma, x is greater than or equal to 0, contains the origin and all points on the coordinate system whose bearing is 45 degrees. Determine the equation of a ray consisting of the origin and all points whose bearing is 150 degrees. Do not forget restriction on the domain that makes this array. So, y'all got it? Filippo's looking like this. All right. So, first of all, there's an example here, which takes up the first sentence. Okay? That is my example. The next sentence is, let's try it again. Okay? So, why don't you just split your page and we'll work with the example over here. Now, when they give me this inequality, we had them give me some inequalities like this a week or so ago. What are they telling me?
X is greater than or equal to 0.
Thank you, Captain Obvious. You read very well. All right, tell me what that means to you. If X is greater than or equal to 0, what are they trying to say?
1 or 4.
For huh?
1 or 4.
Quadrants 1 or 4, right? We are in quadrants 1 or 4 because our X values can only be positive, right? So as I am going to draw.
Good morning. Please rise for the pledge.
Pause right
I
there.
pledge allegiance to the flag of
For the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now the Texas flag.
Honor the Texas flag.
I pledge allegiance to the Texas, one state under God, one indivisible. Please remain standing for a moment of silence. Thank you. You may be seated. Reminder, we do not lock doors open on campus for any reason ever. If you see a door,
I don't even know how that got onto you.
you.
Just you are a creature of habit.
If there are any issues, please come to the student's office. Early college, high school applications are due this Friday by 8 a.m.
That's for
Students,
7th grade.
you'll be voting on superlatives starting Monday, February 10th. Every student will receive an email with the Google form to vote. Students will need to vote only one time for each person in each category. Voting will remain open until Friday, February 14th at noon. Please check your emails and vote this week. This year, BTA will be selling teddy bears. Orders will be delivered to students' homeroom or advisors during on Valentine's Day. Teddygram options. Option 1, small teddy bear with artificial rose, small candy bag, and your personalized message for $10.
That's a
Option
bargain.
2, 12-inch stuffed teddy bear with extra candy and your personalized message for
More candy.
$15.
Bigger bear.
Option 3 is both options A and B for $25.
Big bear. Little
Today,
bear.
eat ice cream for breakfast day and National Frozen Yogurt Day. Today's quote of the day.
Is it really? I haven't even paid attention.
Take a deep breath, smile, and
Like
smile.
they said, they said it like it's a deal, like you can buy both for
And
the
please,
same as
Good,
buying-
because you're gonna buy them separate.
IOUs. Thank you. Have a great day.
I guess this is if you want to send them both to the same person as opposed to sending the big teddy bear to your favorite girlfriend and the little teddy bear to your backup girlfriend when she's absent. Not a good idea. No, Valentine's will not go well. Oh my stars. Okay, so we have at least figured out that we are only dealing with this side of the graph. All right, what's a ray?
It's, a line with a starting point.
Okay, so it's part of a line. So you've got one starting point and you go on forever in one direction. Okay, now, so here's what we got going. We know we're drawing a ray. All right, it has a bearing of 45 degrees. I only see the 45 degrees. Yo, look at me. It doesn't say it is a 45-degree angle. Its bearing is 45 degrees. Where do I bear from? Where does it? Thank you. All right. So if I'm coming from north 45 degrees, we can pretty much eyeball that, right? Now, why do you think I'm just drawing a ray and not an entire line? Okay, because check this out. What the heck is this? Go back into algebra. That is an equation. Okay, now he got it too. It's kind of funny. Filippo drew it from, this is the parent line. Okay, Filippo drew it from bottom to top. You drew it from top to bottom. Y'all both drew this line. But they want me to draw a ray, right? Because I'm not going to draw the part over here, huh? So I am drawing this ray that has a bearing of 45 degrees from north. Agreed? Okay? So that's kind of what they're letting you know. And this has the equation y equals x, but wait, that's the equation of an entire line. So I gave it a domain restriction, right? I said that x could only be values that were greater than or equal to 0. So this is the equation for that ray. Kind of got an idea what we're talking about now, a little bit better than we did right before we went into the pledges there. So the next sentence is asking you to determine the equation of a ray. It's kind of got lumpy there, consisting of all points whose bearing is 150. So maybe we should start off with a little XY graph. Again, we're using method 1 or method 2 here. How did you know that it was method 1? Okay, it says bearing, but then a minute ago they said use both bearing methods, so that's not your best key to know. Okay, it went over 90 degrees, so we can't do that in method 2, right? Also, we only see a degree. We don't see north and west or south and east or any of the, we don't have any directions given to us. If you don't see any directions, but we know they're talking bearing of some sort, all right? No directions, we are starting from the north. So how far would I be going if I started at north and started going clockwise? Would I get this far? How many degrees did I just suck up? 90, but I got to keep going. How many more degrees?
60.
Another 60. Can we eyeball 60 from here? Okay, like maybe that-ish. We got 90 degrees there. We got 60 degrees there. We have done a 150. Do you all agree? Okay, so now we've got the picture in our mind, but we need the equation for this line. How do we write equations for lines? What's one of the formats that what's like your favorite format for the equation of a line?
MX plus B.
I like that one. We could use y equals mx plus b, couldn't we? All right. Familiar with that?
Yeah, but it's Q. Maybe but it's Q, not B.
Oh, Q. Okay. Why Q?
It's quote, like, not quote. Like, it means altitude.
Oh, so it's your y-intercept then. Okay. All right. I don't know why it's the B is the letter that we use, but it works for me because I've taught the little Algebra 1 kids, and I always say it's where you begin graphing. And they're like, oh, it's the beginning amount. And then they start hearing that in their head. Sir.
Maybe someone, when they were copying this problem down to America, flipped their paper over.
The Q turned into a B. What about, okay, that could have happened. Could have happened.
Wait, is it a lowercase q or is it capital Q?
Okay.
It definitely happened.
Could have been. Okay. So, and Q is What? Quod?
Quota.
Quota.
It's like
Yeah.
altitude. Means altitude.
All right.
25.
We are now fluent in Italianese. Okay. Pretty bad there, huh? All right. Now, okay, if I'm going to use y equals mx plus b, and do you use m for the slope? So why m? Do y'all call it slope? What do y'all call it?
Like coefficient angular.
Coefficient. Okay.
Angular
Coefficient of that,
of the angle.
of the angle. Okay. Coefficient. All right.
I'm pretty sure.
I don't know why we call it m, but for me, it helps because m is always a multiplier. So in linear situations, stories, you always have an amount you begin with, like you maybe begin paying $200 plus you pay $25 for every whatever. And so the 25 is a multiplier and the 200 is your beginning amount. That worked out very convenient for me as an algebra teacher. So anyway, y'all, where did this ray begin?
0.
What's its altitude? It's at 0. So we don't really need that because it begins at 0, right? Okay. So we just need to find the slope. How are we going to find the slope?
Oh my goodness, we can do like trigonometry.
We could use some algebra. What do we know about slope in algebra? It is I'll give you a hint. Rise over run. However, when I taught Algebra 1, if I was going down, it didn't feel like I should say that I'm rising and running, should I?
You do like
Falling and crawling. Okay? So if we said, well, what do we know about a 60 degrees? So let's pretend that this is the unit circle. Oh, good for you. What is the ordered pair, that's your little heart, for that angle on the unit circle? And so now we go back to, this is my initial side. What would be, if we were 60 degrees down, like a negative 60 degree angle, what would be the cosine and sine here?
Cosine 1/2.
The
Cosine 1.
sine or cosine?
Cosine.
Cosine is 1/2. Okay. Cosine, we would be running 1/2, right? But we would be rising or falling. Let's make that a negative, and I will have you in the same quadrant as me.
Yep.
So do you agree with that? Okay. Would you agree that slope is equal to the change in y's over the change in x's? Okay. What was our change in y's here? What was our y move? Negative square root of 3 over 2. And what was our x move? 1/2. Okay. So I've got my rise or my fall over my crawl, agree? And what did we learn a week or so ago about these complex fractions that share the denominator? No, whoa. I just pled the whole total wrong thing. But do I really need to keep a 1 in the denominator anymore? So I'm not going to erase it. And so I can put it back so I can knock it out again. So what's the only thing that has survived here? Okay. Now, where else do we see y over x? Tangent. So, isn't this the same as the tangent? Slope is tangent. Okay. It's been hiding. Actually, we hinted about it a week or so ago. One of you brilliant people said something to that effect about a week or two ago. And I said, oh, it's coming up. You're going to need that's going to be important. Okay. I don't remember which brilliant people it was. I don't remember what lesson we were on, but you were alluding to this a long time ago. So my slope is negative square root of 3. So what did they want me to do?
Determine the equation.
Of,
Array.
oh, wait. Okay, let's get the equation going. Okay, so what would my equation be? Y equals
Negative square root of 3.
negative square root of 3.
X.
X, make sure your X does not appear to be under that radical. And we don't have to put our beginning amount because it's a 0, right? So that is the equation, but I think that's an equation of a line, not a array.
Yes, comma.
Comma, give me a domain restriction.
X is greater than or equal to negative. I mean, I said negative 0. I mean 0.
I thought I heard that negative in there. Well, what if your array had been in quadrants 2 or 3?
X is less than or equal to 0.
Okay. Why don't we restrict our Y's?
Because it's determined.
It's a
by
domain
Y.
restriction. It's a domain restriction. Domain X's. That's why. Okay. Now, do these words at the top have some meaning for you? Because a minute ago, I don't know. Okay, you good? Let us continue. All right. Right triangle examples involving bearing may use one method or the other method. Even though it's just so confusing that they call one bearing, the other one direction, and then they call them both bearing. Okay? I could probably call them both directions if I wanted. How are you going to know which method they used? If they don't give you directions, it's method 1, right? Start from north. If they do give you directions, start from wherever they tell you to start. All right. So, okay, I'm going to grab a pencil. I would like to grab a pencil. Are you a pencil? No, you are not. I don't have a pencil up here. I'm going to take a hike to the other side of the room, grab a pencil. If you're using a pen, you might want to use a pencil. You are about to sketch diagrams that they didn't draw for you. So you're going to have to figure out what the heck this story is saying. And sometimes there may be some sketching trial and errors here. All right? So, glad to have you back. You feeling better? Your color is better than 2 days ago. Did you get some rest?
Yeah.
All right.
I don't necessarily feel crazy about that.
Oh, don't worry. You'll have it for another week. Yeah.
I
Okay.
couldn't miss much more school.
All right. All right. A private plane flies for 1.3 hours at 110 miles per hour on a bearing of 40 degrees. Then it turns and continues another 1.5 hours at the same speed, but on a bearing of 130 degrees. At the end of this time, how far is the plane from its starting point?
Far.
Far. See if that answer will get you any credit. All right. So, what the heck's going on here? We got a plane flying. Okay. First of all, maybe we should start by just sketching a north line that we can figure out our first bearing or direction from. Okay? So let's say this point is where the plane takes off. What direction does it go from here?
Probably west.
Okay, we go clockwise. How far?
40.
Oh, I'm looking at the 110. I'm going, where are you getting 40? Yeah, that's the miles per hour. Yeah, we're going to go 40. So 40 degrees from here would not quite be to my 45, right? A little further north than that. So we're going to start off and our plane is flying. How big do you want to make your picture? Is that good enough? Okay, because what's the plane about to do? After it flies for a while, what does the plane do then? It turns. So we need to find our turning point and consider north from there. Now, do we know how long that segment of this trip is?
1.3 hours.
That's a time, that's not a distance.
Oh. No.
Have you ever used the formula distance equals rate times time? We have a rate. We have a time. If you are flying at 110 miles per hour for 1.3 hours, how far have you gone? Y'all all have calculators on your desk. Rate times time. Yes, 143 miles. Okay? And then we're turning, right? Y'all ready to turn? All right. Midair, it makes a turn, and now it's going to go what direction?
North.
Is it going north?
That's inside.
Then it turns and continues for 1.5. So this is just, actually, I'm going to make this a dotted line, okay? I'm going to make my north lines dotted lines because they're not part of the travel. They are just where I'm orienting myself from, okay? Does it say it's going north?
Yeah.
It goes on a bearing of from the turning point, right? So I need to, since it's a method 1 bearing, I need to consider going from north. 130 degrees. What's that going to look like? Can you see my little dots? Okay, I'll help you out here. I just went 90 degrees. Keep going. How much more?
How much did you get there? 40.
Another 40. Can I eyeball 40? A little less than 45, right? Maybe going that away for a while. Same speed. Will it be a longer line segment or a shorter line segment?
It should be longer.
Okay, somebody said shorter, somebody said longer. Give me your reasoning.
It's 1.5 hours.
Yeah, it's 1.5 hours, so you're traveling longer, right? So this time you're going to do 110 times 1.5 hours. And what's the distance you're going to cover this time? 165. 165. Check me out. Do the math. What are you coming up with? 165. Okay, so this line's a little longer than the last one, but I didn't really measure the last one, so at some point, I don't know, something happens, okay? Then, what happens?
We stop.
In midair.
Land.
Okay, we take a little snapshot. At that time, what question did they ask? Well, the starting point was over here, right? The plane's over here, right? So maybe I should play connect the dots. Because they want the straight line distance, which is less than its traveled, right? The shortest distance between 2 points is a line segment. So this is what we are trying to figure out. I'm going to call that guy X. Now, what do we know that I haven't put on this picture yet? Okay, I got 165. Do I have any methods in my toolkit for finding the missing side? What? You can't use Pythagorean theorem unless you have what kind of a triangle? Do we know that that's got a right angle in it? Oh, but Mr. Stewart, that kind of looks like a right angle. We do not trust our eyes. We only trust the facts. Is it a right triangle?
It was like,
Hey!
Oh, the screen's squeaking.
Okay. I'm sure Kylie's wondering what's going on here. So yesterday, this green rectangle just kept flashing in the middle, and it had to do with where my mouse was.
it would only go away if she
It would-
put the
yeah.
mouse on there.
But now it's sound sensitive. Well, I feel like I should talk really loud now. I'm sorry, the people next door are wondering what's going on, but now y'all can't unsee. It's just a tiny little green thing at the bottom of the screen. It's kind of cray-cray here. I don't know what's going on. All right. Do I have enough information to show that I have created a right angle up there? I don't know how to work this problem unless it's a right angle, but I can't just say yes because 2.5 says more right triangle applications. That's not reason enough. Where is my proof?
Well, we have a 40 here.
We have, okay, so we got, which 40 are you talking about? We got a 40 right here. Is this the 40 you're talking about? Okay, we've got a 40 right here, don't we? Agree? Okay,
So that means
We have one there.
that doesn't have to.
okay, all right. Remember the alternate interiors from the other day? Okay, there's other things that are helpful. I have my two north lines are definitely parallel. Would you agree? Okay. And then I've got this slanted line coming up. All right. Two parallel lines cut by a transversal. We know that that guy right there is 40 degrees, don't we? Okay. Now, we also know that we're coming down from here. Let's see, what do we know here? How's this going to help me? What is that little note to myself meaning? I don't know what that's meaning. Okay. All right. Do you see the Z that we got going right there? So what, if this is 40, what is this guy?
40.
Okay. Now that is not that entire angle, is it? That is this part of this angle from the vertical, right? Now,
Oh, and we got opened up 130.
okay, so if we looked at all this, we spent 90 degrees
That's
right here, and then we went an extra 40 degrees right there, right? Do you agree with that? Or I could have just said the one, actually, I think the 130 would be a better description. So we know we went, put that line back, 130 degrees here, right? And then that's altogether how big of an angle? So 180 minus 130 leaves me with, no,
50. And then
50. Put it with the 40. Woo!
that means we can do
We have a right angle. So now, how can we solve for x? Okay, so proof that it's a right angle.
218.344.
Okay, so to find x, we're going to do the square root of adding, subtracting, what? Adding 143 squared plus 165 squared. Filippo, I know you like to do math in your head, but not that. Okay. I love that you will check your brain before you check the calculator, but I also love that somebody invented calculators. All right. Did it tell me where to round? No. Then use the Stewart standard, which would give me, tell it to me again, Lane.
218.344 miles.
Oh, not degrees? All right. So do you see what you've gotten yourself into by taking my class this semester? Okay. Let's continue this adventure. All right. Turn the page. We got some more. Okay. 2 lighthouses are located on a north-south line. Okay. Oh, method 2. Are you sure? Do you see norths and souths and east and west in your degrees? No, you don't. Okay. But we do know we have a vertical line going north, right? And the lighthouses are located on it. Now, what do we know? We want to know the distance between the lighthouses. I don't know how far apart the lighthouses are. So how about we just draw ourselves 2 lighthouses? Okay. What did they call the lighthouses? They give them names. A and B. Y'all, I don't know which one is A and which one is B. It could be AB. It could be AB. We don't know that yet. But we can figure it out. Because this is not just about lighthouses. What else is it about? There's a ship. I'm going to draw my ship wherever it tells me to draw it. So from lighthouse A, which might be up here or might be down here, there is a ship that is 3,742 meters away with a bearing of 129 blah, blah, blah degrees. All right, now think about it. All right, from the other lighthouse, the bearing of the same ship. So y'all take a look up here. Look up here. I can't say I'm going up from this one and down from this one. I would not run into the same ship, would I? I have to be going up from this one and down from this one and do some triangulation to hit that ship. So using our 2 bearings, first bearing says 129 degrees 43, and that's a tiny little minutes there. Do you think that's from the bottom point or the top point? Where is the skewer of knowledge? I'm missing stuff. Remember when Kylie made me that cute little volleyball and she wrote all these inspirational sayings on it? It used to sit on my desk in that little roll of tape. It's gone. I noticed it yesterday. The skewer of knowledge is gone. Those afternoon classes are smurfing my stuff and making me mad. I don't even think I have a backup skewer of knowledge. I made that at calculus camp. I'm mad now. Okay, well, take back the part about the ball. The ball is in the drawer, so that's good. Possibly the afternoon teacher thought it would be safer. But I don't have a skewer of knowledge. What am I going to do, people?
Never have knowledge ever again.
The Go Army pencil of knowledge is just not the same thing.
You'll never ever have knowledge again.
I'm so upset. I have kept that skewer for years. So it was a little wooden skewer that had a little wooden bead hot glued on it that I made at calculus camp one summer. I'm brokenhearted. Okay. Starting somewhere on the line, I don't even care anymore. What if I said the ship is 129.43 degrees minutes, 129 degrees, 43 minutes away? How far would I turn? Because I'm going from north, right? I would go 90 and some more, right? Can I be doing that from down here?
No.
So that's got to be from the top. This is Lighthouse A. Okay? So I'm going to kind of eyeball. What's 129 if I subtract 90 from it? About what?
Like,
41.
Okay, that's almost 30. Throw another 10. Almost 40. Y'all agree? Okay, so I'm gonna just eyeball this. I'm going down 90, another 40-ish. I'm gonna start off this direction. I should probably be using a straight edge, but I've got some pretty good straight drawing skills going right there. Okay? Now, y'all, this is not necessarily drawn to scale. I don't have a clue how far these are apart. I just happen to randomly slap them on the paper. Okay? Now, what about the other lighthouse? What's it called? How would I get to the ship from lighthouse B? Or if I'm standing in the top of lighthouse B, how far would I turn from north to be facing the ship?
dang near 40 degrees.
Dang near 40 degrees. Okay. So something like maybe that's looking kind of 45-ish, isn't it? Maybe a little more northward, something like that. Okay, so what's happening right here?
They met where the ship is.
That's the ship. A capital ship on an ocean trip. Okay, so we've got a ship right out there. It formed a triangle. Is it a right triangle?
Not that we know of yet.
How could we find that out?
With math.
How? We got to prove it. We know that this angle right here was how big? And 43 minutes, right? What other angle do we know?
39.
Where's that?
On B.
Right there. 39 degrees, 43 minutes.
Which means.
What am I going to do with that?
They have little inside parts now.
180 minus 120.
180 minus 129.43 would be, okay, well, 60 minus 43 is 17 minutes. Borrow 1. So it'd be like, yeah, it's 50. You good? Good job there, buddy. Okay, can I tell my degree from my minutes there? Okay, I need to come in closer because I'm writing so small. I don't know that Kylie can see this in her video. Everybody say hello, Kylie. Okay, that was real enthusiastic. 1, 2, 3. Hi, Kylie. Okay, well, sorry, I cannot muster anything more wonderful from these people today. Geez Louise, how am I going to know if I have a right angle? If these two add up to 90, this has to be a right angle. Y'all, what's 43 plus 17? 60. Okay, carry that 1, that makes this 40 plus 50. Oh, we have a right triangle. Yay! Now, what's the question you want me to find out?
Find the distance between the lighthouses.
Okay, so we can call this guy X. How am I going to find that distance? I don't have any side lengths. I do. I was lying. You were supposed to say, no, Miss Stewart, we know these things. Okay. Or do we have, we know from Lighthouse A, the bearing or the ship is 3,742 meters. Now, does it say from Lighthouse B, the ship is, okay, so we can't use Pythagorean theorem. We got Sokotoa going, and that will be where we start tomorrow. Okay? You should continue working on your review. What is due to me tomorrow? 2.4. Yeah, we're working on 2.5, so you should be wrapping up 2.4.
Did you say 2.7?
I did, because I read the 2-7.
Did you turn in your major grade to me today? Worksheet, major
Just the
grade?
major one.
It's your moneymaker here. All right, goodbye, teenagers. Somebody open the door. I am sure Ranger's out there wanting to learn.